Welcome to section 7.1, the triangle application theorems. Our objective for today is to apply theorems about the interior angles, the exterior angles, and the midlines of triangles. For homework, we'll be working on page 298 to 301, numbers 1 through 12, 15 to 18, and 21. First thing we have to talk about is some definitions. First definition is exterior angles. An exterior angle is an angle that is adjacent and supplementary to the interior angle of a polygon. Our second definition is of a midline. For a midline is a segment that connects the midpoints of two sides of a triangle and is parallel to the third side. Let's draw those out real quick. Here we go. An exterior angle. If we have a triangle, an exterior angle is going to be an angle that's going to be outside, but attached and supplementary to an interior angle. And that we know we've discussed before. Now a midline, this is the first time we're going to see this. If we have a triangle, and we know midpoints of two sides, so here's one midpoint, here's a second midpoint. If we connect those midpoints, and it's parallel to the third side, to the side that we didn't touch, that's going to be our midline. Next, we're going to talk about our theorems. Our first theorem is the sum of the angles of a triangle equals 180 degrees. So that's really nothing new to us. Our second, the sum of the exterior angle of a triangle is equal to the sum of the remote interior angles. So let's draw that out real quick. Here's our triangle. Here's our exterior angle. We'll call this exterior angle angle 1. The remote interior angles are the non-adjacent angles that are inside our triangle. So we'll call this angle 2 and this angle 3. And what this theorem says is that the measure of angle 1 is going to be equal to the measure of angle 2 plus the measure of angle 3. Our last theorem says the segment joining the midpoints of two sides of a triangle is parallel to the third side and half the length of the third side. So here's what we have. If we know that we have a midline, so we know it's attaching those two midpoints and is parallel to that third side, whatever the length of the third side is, that midline is going to be half its length. Okay, now let's start some examples. For our first example, we're given the diagram as marked. We're trying to find angle X, Y, and Z. So here's what we're going to do. We're going to use one triangle at a time, and for me, I'm going to be starting off with this big triangle on the left. I already know two of my angles. I know I have an 80 and a 65, and the third corner is actually this angle Y. So here we go. I'm going to add up my 80 and my 55, which is going to give us 135, and we know the sum of a triangle is 180. So take 180 and minus 135, and what's left is 45 degrees for angle Y. Next, I'm going to use this triangle over here on the right. And again, we know two of our corners. We know we have a 100-degree angle, and we know we have a 60-degree angle. So the same thing. Let's add those up, and we have 160. We know the sum of the three angles is 180, so we're going to subtract 160 from 180, and the measure of angle X is 20. Now, if angle X is 20, and angle Y is 45, these make up two angles of this little triangle here in the middle. So just like we did with the other ones, let's add up the two angles that we know. 20 plus 45, which is 65, and subtract it from 180. And that leaves me with angle Z is going to be 115. For example 2, the measure of the three angles of a triangle are in the ratio 3 to 4 to 5. Find the measure of the largest angle. Well, let's draw out a picture here. If we know we have ratios, we know that we can associate x with all three of those. So we have a 3x angle, a 4x angle, and a 5x angle. Don't worry about how it looks to scale. We know that when we add up those three angles of a triangle, it's going to equal 180 degrees. So let's go ahead and do that. 3x plus 4x plus 5x is going to give us 12x equals 180. And when I divide both sides to get x alone, I'm left with x equals 15. Now we need to make sure that we're answering our question. We want to find the measure of the largest angle. The largest angle is, of course, going to be this 5x angle. So let's plug in 15 for x, and 5 times 15 gives me an angle that's 75 degrees for our largest angle. For our third example, we kind of have a tricky one. If one of the angles of a triangle is 80 degrees, find the measure of the angle formed by the bisector of the other two angles. So here's what we know. The 180 degree angle, and that this angle here is bisected, and this angle is different, but bisected. So that's all we know. What we're looking for is the measure of that angle that's formed where those bisectors meet. So we're looking for the measure of angle BEC. Alright, well, here we go. What do we know about this picture? Well, when I look at that big triangle, I know that that big triangle is going to add up to give me 180 degrees. So let's do that. We know 80 plus, we got 2 x's to make up that angle. We got 2 y's to make up that angle. Is going to equal 180. Well, let's try and simplify this as much as we can. Let's subtract 80 to both sides. And that leaves us with 2x plus 2y equals 100, which doesn't seem very helpful. But let's simplify this as far as we can. We know that all three pieces are divisible by 2, so let's do that. We know that x plus y is going to equal to 50. Now, on the surface, that doesn't look very helpful. Is x 10 and y is 40? Is x 30 and y is 20? We don't know. But actually, that's not important. Let's look at that small triangle here. We have those three angles. We have angle x plus angle y plus angle BEC. The angle that we're looking for is going to equal up to 180. Now, we can use substitution on this x plus y. This x plus y, although we don't know what either one of them is, we know their sum is 50, which means that we can actually solve for the measure of angle BEC without knowing x or y. Let's subtract 50 to both sides, and the measure of angle BEC, the angle that we're looking for, is 130. So on the surface, things could kind of look like we don't have a clear-cut answer, but in actuality, we're not just substituting in for x or y, but we can substitute in for a sum as well. Okay, for our last example, given our picture, we're going to find the length of segment AB. Well, what I know I have right here is I know I have a midline. It connects the midpoints of two sides of a triangle and is parallel to the third side. So I know two things. One, that the length of this midline is half of the third side, or we can actually go in reverse as well. One way to make them equal is to take half of the third side, but what's the opposite of taking half of the third side? You can double the midline. So whichever one works for you is what we're going to go with. So I'm going to show you how both of them look. Half of that third side is going to equal your midline, which is what the theorem says exactly. Our other option, which is the exact same thing, instead of taking half, we can do the opposite to both sides, times both sides by 2 over 1. If you double that midline, it's going to equal the third side. Both of them have their advantages. This uses the theorem directly, and in this case it would be nice and easy distributing a half to both sides. We don't end up with any fractions, we don't have any decimals. If you want to make sure that you never have a decimal or a fraction, not to say it's a bad fraction, it's just a half or a 0.5 decimal, you can always just double that third side, or that midline side. So here we go. I'm going to do that option. Multiply both pieces through by 2, and I get 2x plus 14 equals 4x minus 16, and start solving. I'm going to subtract my 2x to both sides and add my 16 to both sides. That leaves me with 30 equals 2x, so x is equal to 15. Just to make sure that you know it works, we're going to do it to the top one as well. I'm going to distribute the 1/2 to both pieces. That gives me 2x minus 8 equals x plus 7. I'm going to subtract my x to both sides and add my 8 to both sides, which leaves me with x equals 15 as well. Both answers will match. Now we want to find the length of AB. So I'm going to take that 15 and I'm going to plug it in. 2 times 15 is 30, minus 4 lets me know that this piece right here is 26. If this piece is 26, because it's a midpoint, this piece is 26 as well, which means that my full length of side AB is going to be equal to 52. Here are the answers to the homework. Again, we had questions 1 through 12, 15 to 18, and 21. If you have any questions, make sure you ask them tomorrow in class. And as always, have a good one.